Hello, my name is Anna, and I'll be going over balancing complex redox reactions and why they're important to everyday living. As a quick overview, I'm going to briefly go over what a redox reaction is and parties involved. If we look at the picture to the right, we see orange circle A has 2 electrons and loses them, which means it is being oxidized, so it is then the reducing agent. Here the turquoise circle is gaining 2 electrons, so it means that it is being reduced, and by definition, it is the oxidizing agent. Step 1. We start with the full equation and split the redox reaction into 2 half reactions by one being the oxidizing and the other being the reducing. Then determine which is being reduced and what is being oxidized. Since MnO4- is getting electrons, it is the reducing reaction, and S2O3 is losing, so it is losing electrons, so it is oxidizing. The oxidizing agent would be MnO4- and the reducing agent is S2O3 Step 2. Balance mass. There are 3 steps after splitting the redox reaction. We have to balance the atoms that are not oxygen or hydrogen. We don't have to balance any atoms here because the MnO4- and the Mn are balanced, as well as the S2O3 and the S2O6 So we're fine for the first step. Next, we balance any atoms that need more oxygen by adding 4 water molecules to the Mn2+ and 3 H2O to the S2O3 Since we added water, we also have to add H atoms to the other sides of the half equations, which we added 8 hydrogens to the first because of the 4 water molecules on the other side, and 6 hydrogen to the second because of the 3 water molecules on the other side. Step 3. Balancing charge. Now we balance the charge by adding electrons. S2O6 needs to gain 3 electrons to become S2O3 and the same thing is done for MnO4-, but instead adding 5 electrons to become Mn2+, because MnO4 has an oxidation state of 8 and Mn is 2+, hence why we need to add 5 electrons. The electrons need to be equal in order to cross out. Step 4. Combine the half reactions. The electrons need to be equal in order to come out, like I mentioned in the previous slide here. Or in the last slide. My bad. Here, MnO4- has an oxidation state of 8- and Mn is 2+. They cancel out to be 5, so that's why we need to add 5 electrons. The electrons need to be equal in order to cross out, so we have to look at the bottom half reaction too. Now we look at S2O6 and see that it needs to gain 3 electrons in order to become S2O3 Next, we multiply the top reaction by 3 and the bottom by 5, so that to then fully be able to cross them out. Now we basically add everything together to make it a full redox reaction again. Step 5. Check the mass and charge are balanced. The title explains it all, really. Just make sure that everything is balanced, and which it is, because the Mn, the H molecule, the oxygen, the S2O3 all cancel out, and that the charge is balanced as well. So that's how we do a redox reaction. As I'm beginning to close this presentation, I just want to go over a little summary about how redox reactions were the transferring of electrons and how to determine the oxidizing party and reduction party. We split 2 reactions, balance the mass so the products equals the reactants, balance the charge, combined reactions, and made sure to balance and cancel the electrons. Then we double check that all the previous steps were correct. So why are redox reactions important to you? These reactions happen when we don't even think it's happening. So the mitochondria use redox reactions to create ATP. So without redox reactions, we wouldn't be able to survive, really. And without these reactions, our phones, TVs, laptops, cars, and other electronics wouldn't work. In redox reactions, the electrons move in a current-like flow. So when we plug in our devices, it allows electricity to flow so it can charge. Alright, so that is my presentation, and I hope I may have enlightened you on this subject. And I want to thank you for your time.